All right. Thanks very much for the invitation. And I will just say from the outset, of all the things I've worked with, cover crops are probably the most regional specific. And so I just want to say that, I would hope that you would rely on, I know Dr. Laux is retired, but he's a good friend and colleague and done great work over the years, but Alyssa is filling in for him now. Just rely on local data. Now, that's not to say that what I'm going to say doesn't apply. I'm just saying there are differences across states when it comes to cover crops, perhaps more so than anything that I've ever seen before. So there's really three different topics that I'm going to talk with you real briefly about in this less than an hour today. And the first one I like the most, it's what can you actually expect from cover crops from a weed control standpoint. I realize there's a ton of reasons why you might be or planting cover crops, and not all of those reasons are weeds, okay? But I think it is important for us to understand what you can get out of them. And the second thing we're going to talk about is termination of cover crops, which is probably the most pressing thing that we should be thinking about as far as timeline goes. And then the third thing I'll cover real briefly is just what kind of herbicides you can apply in your crop system now, this coming season, corn and soybeans, that might be a watch out for cover crops that you plant in the fall, so carryover. So those are the three things I want to talk about. We have done cover crop research for more than a decade in various forms and fashions, and still are. I don't think cover crops are going away. I don't really know where they stand in this state and what y'all's opinion of them is and how much you are adopting them or anything else. But in my state, we grow a little more than 1 million acres of just cover crops. It is mostly cereal rye, not exclusively, but mostly, and they are on the increase. There's no signs that we're slowing down. So I'm going to get right into it here. So first topic is what kind of weed control can we expect? So throughout this presentation, I'm just not relying on my data. I'm trying to rely on multiple states' data, other people, not just us. Certainly we have our share, but and so as I look through all the published literature, which is what we scientists look at, I'm not going to spend a whole lot of time on the topic of winter annual weeds and cover crops, because quite frankly, that's kind of the no-brainer of all of this. That's what they're made for. That's what timeline, and that's what suits the biology of the weeds. So in other words, what I'm just going to say in a nutshell is cover crops, you put them out there in the fall to so that you don't have winter annual weeds, and they do a good job at that. So I'm not going to show you a ton of data, but the real question comes with summer annual weeds, and that's a whole different ballpark. So just a few thoughts. It's nothing is 100%. I don't sell silver bullets. It's dependent on the time of winter annual weed emergence, so that might be one of these regional differences. For me, in my geography, cover crops pretty well cover up the time of winter annual weed emergence. We don't have a lot of issues with winter annuals emerging outside of the time, either before or after, or significantly after in the spring or anything like that. And it's with everything I'm going to say today about weed control, we cannot just generally say that all cover crops are created equal, because they're not. They are not. Different cover crops provide different levels of weed control, okay? If you don't listen to anything else I say, listen to that, okay? So, and we'll talk about some of that, especially when it comes to summer annuals. So I know it's probably hard to see this. It is for me. My eyes are pretty old, but all this is trying to show you, I believe it was from Nebraska, and it's the general timeline of winter annual weed emergence. And I'm just trying to reemphasize to you through data that cover crops are meant for winter annual weeds, and they can do a good job on winter annual weeds. And I think if there's anything that's consistent across the literature, it's that generally they are going to give you winter annual weed control. And, you know, so for us in our geography, I'm not even sure what to call mare's tail or horseweed anymore. It's not a winter annual. It never has been really, but it kind of has been. I don't know, but it can emerge in the fall or the spring, and it grows throughout the summer and then produces seed. Probably one of the biggest success stories for us in our state with cover crops is the I'm certainly not going to say complete elimination of this as a weed, but it is certainly reduced in its the degree to which we have problems with mare's tail. I do not get anywhere close to as many calls as I used to, and I attribute a lot of that to our cereal rye cover crop practices, a lot of it. So probably one of the most successful stories of cover crops is mare's tail, because it fits the biology of mare's tail. Mare's tail could come up in the fall. If we get this cover crop planted and sown, it covers the soil, and it creates an environment where the mare's tail is just not going to germinate and emerge. All right. So like I said, I just only got so much time, and I can't try to prove to you about the winter annual, so I hope you just believe me. So the biggest thing that is the big question mark with cover crops and weed management is, what does this actually do for summer annual weeds, you know? And that's the big one, because there's a lot of different states coming up with a lot of different answers, and I go back to my regional differences thing there, because your climate and your temperature does matter and is different than mine, and same with Iowa or whatever. So all of that stuff matters. So there's 4 things that I think I want to just touch on briefly about, you know, what matters. And the first one is the cover crop species that you select. And again, I know it's really hard to see this, but if there's a way this is being recorded or something, you can go back and see it. I would encourage you to do so. So on this side, the laser doesn't really show up on that screen, does it? So on the side, on the left-hand side, you have all these different types of cover crop species, and what is being measured is basically the degree of weed management you get from that cover crop. And all I'm trying to show is on the very bottom of the screen. I know you can't see it, but the last one is cereal rye. There's a reason why we, as weed scientists, like cereal rye, and why farmers and really the whole industry has gone towards it. And those reasons are basically twofold. Of all the cover crop species, it produces, at least so far, to my knowledge, the most biomass that we can get in a fairly short period of time. Biomass is important for weed control. Secondly, it's allelopathic. It emits chemicals out of its roots that prevent the germination of weeds. So that's all I'm trying to show here. Wheat is down here as well. I think it's like 4th from the bottom. We've seen that some of our growers would just rather throw some wheat out there, but mostly in our state it's going to be cereal rye. It might be a cereal rye legume mix, but it's definitely going to be mostly cereal rye. So the cover crop species influences the weed control you get. And I wanted to show some Ohio data, because this is a multi-state project that Mark Laux led from years ago. And I know it's kind of hard to kind of gather everything that's going on here, but if you just look at the white bars, those are really the absence of any herbicide and everything. If you just look at the top graph with the white bars, and so what you see on the left-hand side is no cover crop. In the middle, it's cereal rye, and on the right, it's spring oats or tillage radish. And I just didn't want to come here without including some Ohio data, so I threw this slide in here just to say and to back up my statement about the species matters, okay? So cereal rye at 21 days after planting is giving us about 40% control of water hemp, whereas no cover crop gave us about 5% or so control, and then the spring oats or the tillage radish gave us maybe 10, probably, that's being generous. And so that, again, that's 21 days after planting. We were a part of this project with Dr. Laux. We were one of the states. I can't remember how many states that there were, but this graph actually shows you a couple of things. First of all, that there are differences in species. You cannot just say everything's created equally. It also shows that spring oats or tillage radish is not so great. In our geography, tillage radish is going to winter kill every single time. And so there's a couple of things. And then the last thing I would say it shows is that, do you see anything approaching 100% control here on just cover crops? No. I mean, this is just one tool in the toolbox. It can offer you some suppression of water hemp, but I really get frustrated with people that are taking marketing of the cover crops too far and saying that you're going to get some kind of season-long control out of water hemp. I can tell you, I'm in a state that's got water hemp 10 times as bad as you do, I would guess, okay? And we do not get anything close to season-long control of water hemp out of our best cover crop. Now, I'm a proponent of cover crops, okay? But at best, they're giving us early season suppression, and at best, I would say sometimes they're keeping us from to apply one herbicide application that we maybe normally would have. But that's at best. There's still going to be water hemp come, and there's still going to be a time when we have to spray and kill the water hemp, okay? Just some data from somewhere way far away from all of us, just on another pigweed. It's Palmer amaranth. And I'm just trying to show you the same kind of thing, that there are differences in different cover crop species. And so the difference here in what they did in Georgia is that it was either, if it says minus cereal rye, that means it was just Austrian winter pea, vetch, or Clemson clover alone. And then if it says plus, it means it's a cereal rye vetch mix or a cereal rye clover mix, et cetera, et cetera. I'm sure you can figure that out. But I just wanted to explain that all to you. And all I'm trying to show you here is that, again, it is not 100%. There's still going to be, in this case, Palmer pigweed that comes, and that there are differences in the species out there. The amount of cover crop biomass accumulated is a huge factor in what kind of weed control you're going to get. There's a lot of meta-analyses out there now, and all that means is scientists like to do this. I like to show and I like to look personally at the results of meta-analysis because it's the results from a lot of different locations across a lot of different states. And basically what both of these lines are showing is that with the more biomass that you get as you go from left to right on these graphs, and you see those lines going down, well, that's the weed density or the weed biomass that's happening. So you want the lowest amount of weed density or lowest amount of weed biomass that you can get. And so you need as much biomass as you can get. And as I've already told you, cereal rye is one of the ways that we get the most cover crop biomass out there. So one of the things that's being thrown around in the past couple of years, just 2 or 3 years, is the results from this study, which these guys, they looked at a lot, just basically every type of cover crop and weed data that they could find, and they were trying to get to what's the amount of biomass that is required to give me a certain level of control. And so since they published this, I've been hearing this number over and over, and it's kind of what everybody's shooting for now, is that if we get 2.2 tons of biomass out there on the acre, we can get at least 75% weed control. So I don't know, I don't know how you gauge whether you've got 2.2 tons of biomass out there or not, but that's the number that's being thrown around from a scientific standpoint. This is a part that I thought was even more interesting, and the reason I thought this was more interesting because it illustrates one of my points about regional differences and the fact that climate and it plays a role in all of that. And so in order to get, what would it take? I mean, like, so they tried to figure out through some modeling and everything else, what would it take to get to 2.2 tons per acre? And that is going to vary based on where you are, right? I mean, it only makes sense. So this group was out of Iowa, and so they, if you notice, I don't know if you can even see it, but in the middle of the screen is like 17 June. If they planted on the 7th of October their cover crop, then it would take them until the 17th of June to get 2.2 tons of biomass per acre. I don't know about you all and what you do in this geography, but by the 7th of June, we got soybeans that are probably knee-high, okay? And so that wasn't very encouraging to me, but again, that was data for Iowa. So I went and I looked, I said, okay, what did they figure out for Missouri? So if we planted our cover crop by the 7th of October, then we could expect 2.2 tons an acre by 17th of May, 1 month sooner, okay? So what they're saying is cover crops should be able to give me, in my geography, a little bit better weed control, a little bit more realistic time frame that would work with our systems than in the further north you go, okay? So that's what all that's saying. And they do have something for Iowa, so they figured if you got your cover crop planted by 7th of October, Ohio, if you got your cover crop planted by the 7th of October in Ohio, they said the 2nd of June you would get 2.2 tons per acre. So I don't know how encouraged you are by those numbers, but the thing to think about is, well, if that's true for me and my geography, what could I do? What are some of the things I could do to make that happen earlier? Okay, if you're worried about that 2nd June date, which I would be. Well, the things you could do is plant your cover crop earlier. There's all kinds of research going on with interseeding into existing cover crops and all of that, and into existing cash crops and all of that. And then the second thing I think about is this whole thing of planting green. And I will talk about that eventually, okay? Just let me get through some of these things, but I am going to talk about that because planting green is basically the way everything is going in the cover crop world, at least in my state. It has gone there pretty quick, okay? All right, so we're going to come back to that whole issue of planting green. So again, I can't tell you what it requires to get to 2.2 tons of biomass per acre if that's what you're shooting for. All I can say is there's our studies and there's other studies that have been done that says once you get to a certain seeding rate, you don't need to keep on increasing. It's not going to influence your total biomass. And the problem is this is one of those regionally specific things. It's probably going to vary. That number is going to probably vary depending on where you are and all of that. But for us with cereal rye, basically, you know, we're telling our growers that somewhere in between 50, 70 pounds of cereal rye per acre, you're really not going to get any huge weed management benefit by going above that. Now, if you want to, that's great. It's fine. Like I said, cereal rye and cover crops are planted for a lot of different reasons. So if you want to go out there 90 or 100 pounds per acre, which a lot of people are, we are not going to complain at all. But, you know, from our standpoint, we don't see the weed density really being impacted above certain levels. I think that's just saying the same thing I just said. Well, this is just some of the data on biomass at planting. But again, this was dependent on when we planted it, what time of year we planted it, and when we terminate it. So that's going to influence your biomass. There's been another study that did some cereal rye seeding rate, said that this was in the mid-Atlantic U.S. I think this was some Pennsylvania data maybe, or I can't remember all the states that went into this, Maryland. So a little bit closer probably to where we're sitting maybe. But anyway, their data was saying you didn't even know to go as high as what we said. There's more like a 45 pound per acre. So again, you fit what you think is best for your operation, but there is a cutoff point where you're not getting the benefit in weed control after a certain level. So this whole idea of when you terminate and decomposition. So I'm going to talk a little bit about decomposition. So another thing that's going to affect your weed control, it's also affected by what cover crop species you selected, and that is how quick does that thing break down? I mean, y'all know this just from looking in the field, but if you've ever had like spring oats out there or tillage radish or even crimson clover or something, does it persist? The residue, does it persist on the top of that soil as long as cereal rye, or does it break down quicker? So that's stuff that matters, right? Because the longer that residue persists, the more weed control you're going to get. And so this is just one study out of many that shows that cereal rye has a higher cellulosic content than most of the other species that we're evaluating. I mean, if you want to ask me what are some of the things we ought to be trying to do with breeding and maybe even, I don't know if it'd be classified as a GMO or what, but we should be breeding cover crops for more cellulosic content and not breaking down as quick as they do. And that could actually contribute to our weed control dramatically, okay? So it matters about how quick it decomposes, okay? And then, of course, the last thing that matters is the type of weed species that we have out there. Not every weed is going to be created equal either. The pigweeds are what I focus on, and water hemp is mainly what I focus on, and that's a very small seeded weed. And we have found that cover crops actually do well. They actually do something for water hemp. On the contrary, giant ragweed, which is a much larger species, maybe not as much as what you get for water hemp. So it does matter about the weed species out there. So we kind of adapted this from somebody that published this years ago, just kind of a theoretical scenario. If you have a winter annual weed that comes up in September and germinates and can germinate all the way through almost December, or you have another type of winter annual weed that germinates in December and can possibly do so in January and February. Well, if you've got a cover crop that was out there and established well, that can override. I mean, you can see, this is just my simplistic way of looking at it. That can beat out those two winter annuals, right? And that's really what's happening with our cover crops for the most part. But if you have a summer annual weed that comes up in April, May, June, and July, which in our geography, that is water hemp. It can come up, and I just keep on going. It comes up in August in certain situations. So, it's asking a lot for the cover crop to actually work on that summer annual weed full season. And so we've got to get something that gets us the rest of the way. And so far, I would choose a cover crop that doesn't break down as quickly or has allelopathic properties or both as my way to get the rest of the way. But it's probably never going to completely eliminate herbicides. And that is what we've seen with water hemp management in cover crops. It is not, I can't say, I've said this like 10 times in my 2 talks today. There is no silver bullet, right? And so we just have to understand the system and what we have. All right, so I am going to come back to this whole issue of planting green. Believe me, I haven't thought about it. These other 2 things I think I can get through pretty quick. But the next thing that we're probably going to be talking about and thinking about is terminating. And so we were a part of some more multi-state projects that did termination work. And so these graphs are all there's a lot you can't see that are in the small writing, but it says all the details. And so box and whisker graphs are something we often use for data that have multiple sites that show you the range in the data, the variability in the data, and the tightness of the data and all of that. So the smaller the box, the better, and the less whisker, the better. And so that's what you want to look for. And so this is percent visible control 28 days after the treatment. And what you can't see was on the bottom, unless you have really good eyesight, which I don't. It says results are an average of 8 sight years across 5 states. And then it says treatments made between April 10th and April 29th on cereal rye that was from 6 inches to 50 inches in height, depending on location. So a lot of people look at that and say, well, that's not, that's a lot of variability. It is. That's kind of what I like. I mean, but not everybody was able to terminate at the same time. So you got data that shows a wide range of possibilities. So the bottom line is with cereal rye, all the pinkish or oranges boxes on the bottom, they're really small and they're really tight. And what that means is we can kill cereal rye still with glyphosate and glyphosate combinations pretty effectively, which is good news. The blue boxes are gramoxone combinations. And while you do have some options there, I don't know that we need to go there. And the green boxes are Liberty or glufosinate combinations. And just quite frankly, and I think everybody readily understands this, glufosinate, we love it. It is a post-emergence herbicide for water hemp. It's not really a burn-down herbicide, in my opinion. I don't know why we would kind of waste it in that way and go down that avenue. And so glyphosate still works. Just some pictures to show you what I'm talking about. A lot of times what happens with glufosinate or paraquat is that we get regrowth because we initially burned it, but then it grows back from there. Wheat cover crop, very similar. Again, I'm not going to belabor all these because I'm assuming you'll have some way to go back and look at this. But if you don't, all of this is on our website. We have a cover crop section and these exact slides on our website, so you can go back and look at this. So wheat is still, it's a little more difficult than cereal rye to control overall, I'd say, but it is still possible. And then one that, I get in trouble for this. I don't care. I'm getting ready to get in a car and drive 8 hours back home, so you can be mad at me. I don't care, but so ryegrass is not the same thing as cereal rye. We have had some problem with that in the past, at least in our state. I don't know if you all do or not, but it's often misinterpreted and not understood. Ryegrass versus cereal rye. They are 2 different species entirely. Lolium perenne, subspecies multiflorum. That's the scientific name of ryegrass. It's the one that might get to be waist high if you're really doing something great. It's really got glossy leaves. It's got a spiked seed head. Cereal rye is more like chest high, bluish green, grain looking, kind of thing, and nothing at all alike. And so most weed scientists, I won't throw everybody else under the bus, but there's a lot of passion around this whole idea of ryegrass. NRCS promotes it a lot and all of that, but most weed scientists don't like ryegrass because it is a resistant weed in the world, and in the U.S. it is a resistant weed, particularly in the South, and there's major concerns about it. And so I'll just leave it at that, but I don't recommend it from that standpoint. And just don't see why we would use that versus cereal rye from the weed data and from the termination data because it's really hard to terminate. And so Larry Steckel down in Tennessee, he's told me many times that now ryegrass has surpassed Palmer amaranth as his worst weed of concern for him. And so that's a pretty significant statement. He can't get it burned down. prior to corn and soybeans. And so here's our multi-state data with regard to ryegrass. And you see how those bars change and everything's jumping all over the place. And the only real tight looking option is glyphosate plus clethodim. And for that reason, glyphosate plus clethodim is our recommendation on ryegrass burn down. It's our standard recommendation. And we've done other studies other than just this one and seen very similar things, but it never fails. I get 2 or 3 calls every spring. It's almost always out of the boot heel where they tend to, I don't know, accept ryegrass more as a cover crop for some reason in my state. In the boot heel, I'm talking Missouri terms here. The boot heel for us is the southeast portion of the state that looks like a boot heel. But every spring I get 2 or 3 calls of somebody that just did not get it terminated effectively. So ryegrass, and this is what often happens. You see that green and up starting to happen. So the soybeans are planted, the ryegrass was burned down, the ryegrass is now growing again as a weed competing with that crop. This is what we have happen time and time again. Yes, sir. Yep. What's that? I didn't hear that. So you're saying we ought to mow it? Is that what you're saying?
No, I said your yard. To judge when to spray ryegrass, you need to at least mow your yard twice in the spring before you attempt to kill your ryegrass. I mean, you got to wait for it to warm up. That's the joke.
Okay. Yeah, so I've gotten that statement from a lot of ryegrass proponents. So, you know, I'll grant you that the time before, and you're going to see that on a slide here in a second, the time before and the time after application to ryegrass matters a lot. The climate, the weather, the environment, it does matter. But just to be quite frank with you, it's just way harder to control. This is a graph that illustrates, you know, this is more detailed research than the multi-state research. We sprayed it 5 to 9 inches, and I thought the dates were on here, but they're not. But these would have been at different dates, so it goes to your point. We sprayed it at 12 to 20 inch in the pre-boot. We sprayed it at 28 to 36 inches in the heading stage. And you can see, I don't know if you can see it or not, but you can see the kind of numbers that we get on control. Not very many of them are anywhere close to 100 until you get to those glyphosate plus Select Max combinations. And so that would be, I would say, any glyphosate plus clethodim is fine there. But so that's what we're seeing, at least in our state. It's very, very tough, and dicamba is probably going to do a little better on most of those, but 2,4-D does just fine with glyphosate. So I'm kind of making a broad statement about all of the legumes there, which might not be so fair, but certainly glyphosate and 2,4-D burn down does well. All right, so just to sum up the termination aspect with a lot of words, proper timing is important. Proper temperature and environment before application may be just as important. I think I mentioned that. That's what we were talking about earlier. As far as species that have proven difficult to control, annual ryegrass is top of the list for us in all of our studies. But then you could follow that with wheat, crimson clover, vetch, Austrian pea. These are literally some of our rankings based on the research we've done for about the past decade. Glyphosate plus 2,4-D or dicamba or sharpen combinations, probably the most consistent across the widest type of species, widest geography. except ryegrass. I would not be something I recommend for ryegrass. Our ryegrass recommendation is completely glyphosate plus clethodim, and really paying attention to all the details, including weather and environment, size, and everything like that. All right. So this, I've got something like 20 minutes or less left. Planting green is what I said earlier. This is where everybody is going, at least in my state. I can't speak for Ohio because I have no idea, but about 3 or 4 years ago, something happened, and our growers kind of flipped a switch without even really us having a lot of research on it, and everybody just started planting green into cereal rye, and mostly what I'm talking about is soybeans. I'm not talking so much about corn here. And so we're kind of playing catch-up in some respects on this, but I'm going to share a few thoughts about planting green and what some of the data says. So the biggest question that comes to me as a weed guy is, so if I'm going to do that, should I include the residual with my burn down, with my product that I'm killing the cover crop with? And when I say cover crop, I'm pretty much, all the work we're doing is in cereal rye because 95+% of our growers are planting cereal rye, and that's it, okay? If that's not true in Ohio, that's why I say you need to go to local experts. So this is something we did years ago to try to answer that question. And so it is the amount of sulfentrazone that's left in the soil when we terminated a cereal rye 21 days before planting, which is on your left, or when we terminated 7 days before planting. And so this doesn't entirely answer your questions about this or my questions, because back when we did this, nobody was planting green, okay? Everybody was terminating either a few weeks before planting or right up close to planting. And so I don't have anything that shows what about if we planted green and terminated later. And so what we found is probably not all that surprising to you. So the black bar is at the time of application. The gold bar is 28 days after application. I think we ought to just probably focus on looking at that because that's reasonable. So how much residue of sulfentrazone, which is authority, how much authority is left in the soil 28 days after application? And so you could see the effect of just later termination. All that biomass that accumulated for that 2-week time frame between the two sets of bars, 21 versus 7, you can see how much difference there is in the amount of sulfentrazone reaching the soil. And so we did this several years ago, and at that time what we said is we think that there is so much pre-emergence residual herbicide that's getting intercepted by the biomass that our recommendation would be just terminate your cover crop and come back into soybeans, V2, V3, whatever it is, and put on your residual then. I realize your residuals are a little bit more limited, mostly to group 15 herbicides, but still, I think there's just way too much loss of sulfentrazone occurring here than it is worth it. So that's what we said a couple years ago. Since then, since then, there's been some other universities that started doing some stuff, and it's made me question my original recommendation. And I don't know that I'm going to disagree with anybody at this point because we don't have enough data. But I guess some other universities are starting finding that, you know what, it is kind of still worthwhile to put that residual out there. Just understand that there's going to be a lot less that actually reaches the soil. But rainfall can wash it off, and that's not something that we looked at. And some researchers are saying, well, it's even almost like rainfall is washing a little bit off at a time. And so I don't know what to say about all that, but that's kind of the new spin that people are taking on this. But, you know, this is some pictures from that study and just kind of goes back to some of the things we were talking about earlier about weed control. This is what we get in Missouri as far as what it would look like. So this is that study where we terminated 21 days before planting, and look how little biomass is there. These pictures were taken 2 weeks after soybean planting. On the right is we terminated 7 days before planting, and look how much biomass is there at that time, 2 weeks after planting. And so you can see I've got some data on how much biomass was actually there. We're meeting that 2.2 tons per acre regardless in our state. Okay, with whatever we do, we're meeting it. But just think about what a picture on the right of both of these would look like for planting green. I don't have a picture like that yet, really, because we haven't done the study, but think of how much biomass would be in there if we planted green and terminated 2 weeks after planting or 1 week after planting. It's probably going to look even more covered. So I'm kind of talking to you a little bit here, digressing a little about weed control. This is why we get the weed control we get, and this is why planting green is being talked about. All right. Sorry, I didn't think that one was in there. That's just a graph of what I just talked about. I made that graph simpler. So here's the new research that's coming out of some other states. Purdue, y'all are pretty close to Purdue. I know Mark, Bill Johnson used to do a lot together. And so what some of their data, from what I understand, is saying that they included roller crimper. I have not done that, but I already just said this, that it's kind of a slow release manner of the pre getting washed off. So that's one thing. Brian Young's got a student. Brian's at Purdue, and he, in his paper, he came out and said soil residual herbicides should be applied at cover crop termination. So I just throw that out there. And then there's some Wisconsin data that I don't really know what to make out of that, but they did not reduce water hemp control, but they did see less Valor and Zidua. So anyway, it's a thing that's kind of up in the air now, and I really think you should be relying on local conditions. Alyssa, Mark Laux, any of your regional extension people, to really try to give you their thoughts on that whole question to that issue. So last thing, I know I'm running short, but it's not going to take long, because this to me is kind of the most boring part of the three things that I'm talking about. That I can sum it up pretty quickly with just a few thoughts, but this last thing is you thinking about what herbicides you use in corn or soybeans if you are going to plant a cover crop in the fall, and what potential carryover is there. And I think I can summarize everything that I'm going to get ready to show you with this. Yes, there are certain active ingredients that are some watch-outs, and I will tell you what those active ingredients are, but it is almost 100% depending on rainfall and weather, and whether you have a drought or you don't, and I'm talking about a pretty significant drought. We have not seen a whole lot of reason to have concern on herbicide carryover with the active ingredients we're spraying in corn and soybean, even when we really try to challenge them. And the only thing that's probably going to impact that is if you have a year with a lot of drought. So if you go on our website, you can see these kind of green, yellow, red kind of graphs and everything. And this is also a result of some studies from years ago. And so I'm not going to even try to go through this. I'm just going to go to the bullet points where I tell you the active ingredients to look out for. But what this is, you know, green was no reduction in cover crop biomass for any year. Yellow, we got reduction in 1 out of 3 years, and red was reduction 2 out of 3 years. So it's a lot. It's a lot to try to take in all at once. So I'm just going to summarize it for you. The other thing is there are differences in the type of cover crop as far as their sensitivity. The most sensitive cover crop to herbicides overall is tillage radish. one of the least sensitive is cereal rye, which is another reason why we like it so much. So there, again, you can't create all cover crops the same. There are differences in the sensitivity to herbicides. That was tillage radish, and this is cereal rye, which you can't hardly see any differences there, right? And so we had another multi-state study, and we really tried to hurt cover crops. I mean, we put on things like authority assist, followed by prefix, followed by warrant. And this was done across several states, and we did it in 2 years, 2016, 2017. We really didn't have any major concerns in drought in those 3 or 4 states. And so what did that translate to? You know, we got like 6-7% injury. You know, that's just not very much. We barely saw any differences at all, no matter what we tried. So it just goes back to my earlier statement of most times we're not going to have trouble with most of the common ingredients that we're applying, but I am going to give you 2 or 3 to watch out for. So this is the cover crop, or excuse me, this is the corn side of things. Again, we have a few things that you need to watch out for. And again, I would say tillage radish is one of the most sensitive. So it's going to be a lot of words, but this is going to back up everything I just said, or say it again. Cover crop injury is entirely dependent on rainfall. Cover crop injury is different by species. This is our ranking based on the data we gathered in all those years. Tillage radish is greater than Austrian winter pea, is greater than crimson clover, is equivalent to annual ryegrass, is greater than winter wheat, is equivalent to winter oats, is greater than hairy vetch, is equivalent to cereal rye. So the least sensitive, the ones that we probably don't have to worry about the most, are hairy vetch and cereal rye. The herbicides that we do have to worry about the most are anything with the active ingredient fomesafen in it in soybeans. That is probably the top of the list. It can hurt some of our cover crops, particularly the broadleafs. Zidua can hurt things like ryegrass. Zidua is actually labeled for ryegrass, and it can hurt some of the other grass species. Again, most of what I'm talking about is if there were a drought or something like that, as well as acetochlor or warrant. But as you saw in those slides, we tried and we couldn't even get that to really happen. In corn, topramazone or mesotrione, the HPPD inhibitors, most of our acres in Missouri get some kind of mesotrione. It can cause problems, again, in dry environments and, again, to some of our more sensitive species. The legumes can be more sensitive to things like stinger. That's a growth regulator that can certainly hurt it. But again, pyroxasulfone or Zidua for ryegrass. So with that, kind of sped through some of that because I knew I wanted to leave a few minutes for questions, and I was running short. But so that's all of our. If you didn't see me earlier, what I said earlier, I'm just glad to be a part of your weed management publication. You see that up here. We're now included. It's a 4-state publication now, and it's always been a great one. And there's just a lot of good things that happen as a result of collaborating with Bill and Mark and Alyssa and Aaron. And then all the rest of that stuff is our social media stuff where you can get a hold of me or just see what we're saying. So any questions whenever we have time for questions?
If you have a question, please raise your hand, and Courtney and I will bring microphones over so we can hear you better.
Yeah, you said you saw issues with carryover with the acetochlor, the warrant. Did you see anything with the dual, the metolachlors?
No, we haven't. Not in any of those studies that I've shown there. I really haven't seen it as a problem with metolachlor. And again, acetochlor, yeah, there's times, I think it's like 1 year out of 3 or something like that. And again, it probably would have been more on those grass species, but Year in and year out, probably not going to see a whole lot of issues with acetochlor either, really, to be honest. If you don't have a drought, which we never know, you know. And we are in these systems where we're doing more layered residuals and we're applying things like acetochlor later, and certainly the risk is there. I guess I don't want to come across as minimizing things, but the fact of the matter is we just don't see a lot of problems with most of our most common cover crops year in and year out. Let's go back here.
Yes, I was wanting to ask about on different varieties of rye. I've been reading there's some studies going on that say that certain ones have more of the active ingredient that does the allelopathy at certain times in their growth stages. So can you comment on what they're seeing?
I can only comment to say that you're exactly right, and there's more research going into that area. It's more of a breeder's project. I know our breeders at Missouri are involved in it. I'm a 100% fan of it. I think that's what we need. We need cereal rye varieties that are more suited to each area and that we can breed for more allelopathic properties and things like that. That's all I know about what's going on. I think, quite frankly, it's pretty new. It's just started, so I don't think there's a lot of data out there on it yet.
And even the maturity of some of the varieties fit better
Yep.
because they mature quicker and we're able to do some things and
Yep.
bring that allelopathy in at the right time.
Yep. Yeah. Yes, sir.
You mentioned in Missouri that most of your cover crop is cereal rye into soybeans. So what are you using for cover crop into corn, or just not cover crop in corn much?
There's not as much because it's quite a debate, at least in Missouri, about cover crops in front of corn and whether we're taking nitrogen away and all this kind of stuff. And it seems like everybody you ask, you get a different answer. But it's not as common at all in corn. But if it is in corn, it's still cereal rye, and mostly people are terminate 3 or 4 weeks before planting, and most of that is because of the nitrogen issue, or the debate about whether cereal rye is taking nitrogen away from the corn. So that's what happens with us. I don't know if I don't want to present us as the poster child for doing everything right, but cereal rye before corn is, if we do anything before corn, it's probably going to be that. But it's just not anywhere close to as common in corn as it is in soybean. Yes.
I'm no expert by any means. I grew up on a farm. We've been cover crops 20 years, probably 10 cereal rye ahead of corn, planting green, no-till. Come talk to me.
No problems, right? So, yeah, I hear that out of a lot of people. Yeah, it's just management, yeah. Yeah, so I hear that out of a lot of people. So I was asked to go talk to the Wisconsin cover crop symposium or something, and there's a farmer before me that gave a talk and basically said what you just said. This is how I do it. I'm not concerned about nitrogen and all that, but we have some of our own fertility people that are, I guess, saying different things. But I guess management is everything, right? If you do the management right, you can make it work.